Hello there. I'm so glad you found your way here tonight. Right now, as you settle in, something extraordinary is happening within you. Trillions of cells are quietly working together, exchanging signals, repairing damage, and keeping you alive with a precision that rivals any machine ever built. Every heartbeat sends a surge of renewal through your body. Every breath fuels a chain of microscopic repairs that never pause, not even for a moment. Healing is not something that only happens after injury. It is the constant, patient work of balance and restoration that defines what it means to be alive. Tonight, we journey into the quiet science of how your body heals itself. We will explore over 100 soothing facts about healing, regeneration, and the remarkable systems that keep you whole. There is no test at the end, no rush, no urgency. Just the gentle unfolding of your body's most extraordinary secrets to carry you softly towards sleep. So let your breathing slow. Let your thoughts grow quiet. And allow yourself to drift into the peaceful wonder of your own biology. Welcome to Drowsy Discovery. I'm glad you found your way here tonight. Perhaps you have had a long day. Perhaps you simply enjoy falling asleep to thoughts about the remarkable processes happening within your own body. Either way, this space is for you. There is something deeply calming about contemplating the inner world of healing. Every cell, every chemical signal, every quiet act of repair carries within it a story billions of years in the making. You are part of that story. The same mechanisms that healed the first living cells on Earth are still working within you tonight. The wisdom of regeneration has been passed down through countless generations, written into your very DNA. If you enjoy these gentle journeys, I invite you to like, subscribe, or share a thought below. It helps others find their way here too, one sleepy soul at a time. But for now, all you need to do is relax. So settle in. Let the weight of the day drift away. And let us begin with the first of many quiet truths about how your body restores itself. Healing is patient beyond measure. Bones mend over weeks. Nerves reconnect over months. The heart beats on for decades, renewing tiny portions of itself with each passing year. And yet, within all that slowness, there are sudden bursts of wonder. Wounds that seal themselves in hours. Immune cells that destroy invaders in moments. Pain that fades as the brain rewires itself toward peace. Tonight, we will wander through this magnificent inner world. We will meet the cells that never stop repairing. We will discover the hormones that guide recovery. And we will uncover truths about healing that may surprise even the most curious minds. But there is no hurry. Your body has been healing itself since before you were born. It can continue its quiet work while you rest. Let us begin with how your body rebuilds itself. Your body replaces most of its cells every few years. The body you inhabit today is not the same body you had 7 years ago. Most of your cells have been quietly replaced through a continuous process of death and regeneration that never stops. Red blood cells live only about 4 months before being recycled. Skin cells are shed and renewed every few weeks. Even the cells lining your stomach are replaced every few days. Some cells, like those in your brain and heart, can last a lifetime. But most of your physical substance is in constant flux. You are not a static object, but a flowing river of renewal, maintaining your form while constantly exchanging your material. The body is less like a sculpture and more like a fountain, its shape persistent while its substance forever changes. Some cells repair the same tissues throughout your entire life. While most cells are eventually replaced, certain specialized cells work tirelessly to maintain and repair tissues without ever being swapped out. Satellite cells in your muscles wait quietly until damage occurs, then spring into action to repair torn fibers. Osteocytes embedded deep within bone tissue monitor structural integrity and signal for repairs when microcracks form. These long-lived repair specialists accumulate the wisdom of experience, becoming better at their jobs over time. They are the master craftsmen of your body, honing their skills across decades of quiet service. Without them, the constant wear of daily life would quickly degrade tissues beyond recovery. The liver is the only human organ that can regrow itself completely. The liver possesses a regenerative power unmatched by any other human organ. If up to 70% of the liver is removed through surgery or destroyed by injury, the remaining tissue can regrow to full functional size within weeks. This remarkable ability has been known since ancient times, reflected in the myth of Prometheus, whose liver was eaten by an eagle each day only to regrow by morning. The regeneration is not quite the same as the original organ, but the function is fully restored. Scientists are studying the liver's regenerative secrets in hopes of someday applying them to other organs. For now, the liver stands alone as the body's most resilient and self-sufficient organ. Your gut lining replaces itself every few days. The cells lining your digestive tract face a brutal environment of acid, enzymes, and abrasive food particles. To survive this constant assault, the gut lining replaces itself every 3 to 5 days, making it one of the fastest renewing tissues in the body. Stem cells at the base of intestinal crypts divide constantly, pushing new cells upward to replace those that have been worn away. This rapid turnover is essential for maintaining the barrier between your body and the outside world that passes through your digestive system. A single day of disrupted gut renewal would leave you vulnerable to infection and nutrient loss. The gut is a factory of regeneration, working around the clock. Bones can sense where they need to grow stronger. Your bones are not passive structures but dynamic living tissues that constantly remodel themselves in response to stress. When you exercise, the impact and strain on your bones triggers a response that makes them denser and stronger in exactly the places they need to be. This process is guided by cells called osteocytes that act as sensors, detecting mechanical stress and signaling to osteoblasts to build new bone tissue. Astronauts lose bone density in space because without gravity, there is no stress to signal for strengthening. The bones know where they are needed most and direct their resources accordingly. They are intelligent structures, adapting to the demands you place upon them. Skin heals itself from the inside out. When you cut your skin, healing begins immediately and works from the deepest layers toward the surface. The first response is to stop the bleeding, as platelets rush to the wound and form a clot. Beneath this protective scab, new cells begin migrating across the wound bed, while deeper layers regenerate the tissue architecture. New blood vessels sprout to supply the growing tissue with oxygen and nutrients. Gradually the wound fills in from below, pushing the scab upward until it eventually falls away to reveal fresh pink skin beneath. The process is orchestrated by dozens of signaling molecules that coordinate the timing and sequence of each step. Skin healing is not random but follows a precise program refined over millions of years of evolution. Your DNA has a built-in repair toolkit. Every cell in your body contains a sophisticated molecular toolkit, dedicated to finding and fixing damage to your genetic code. Ultraviolet light, toxic chemicals, and even the normal byproducts of metabolism constantly assault your DNA, causing thousands of lesions every day. Without repair mechanisms, these errors would quickly accumulate and destroy the instructions that keep cells functioning properly. Fortunately, evolution has provided multiple overlapping repair systems, each specialized for different types of damage. Some systems cut out damaged sections and rebuild them from scratch. Others can directly reverse chemical modifications that distort the DNA helix. The repair toolkit is not a single tool, but a complete workshop, equipped for every contingency. Your genome persists across a lifetime because it is constantly being maintained by these tireless molecular mechanics. Enzymes patrol your genetic code like careful editors. Specialized proteins called repair enzymes continuously scan the 3 billion base pairs of your genome, searching for errors with remarkable precision. They slide along the double helix, recognizing distortions in the molecular structure that signal damage or mismatches. When they find an error, they initiate a complex repair process that removes the damaged section and replaces it with the correct sequence. The proofreading is so thorough that errors are corrected with more than 99% accuracy. Some enzymes work alone, while others form large complexes that coordinate multiple repair activities simultaneously. This constant editorial vigilance keeps your genetic information intact despite the relentless forces that seek to corrupt it. Without these patrolling editors, mutations would accumulate so rapidly that cells could not survive for long. Damaged cells can trigger their own recycling. When cellular damage becomes too severe to repair, healthy cells have the remarkable ability to recognize their own dysfunction and initiate a controlled self-destruction program. This process, called apoptosis, ensures that damaged cells are dismantled in an orderly fashion without releasing harmful contents that could injure neighboring tissues. The dying cell breaks itself into neat packages that are quickly consumed by immune cells and recycled into raw materials for new cell construction. This self-sacrifice protects the larger organism from the dangers of malfunctioning cells, including the risk of cancer. The decision to trigger apoptosis is carefully regulated by molecular sensors that weigh the severity of damage against the cell's importance. It is a form of cellular altruism, where individual cells give up their existence for the good of the whole. Old cells release signals that summon their replacements. As cells age and approach the end of their functional lifespan, they begin releasing chemical signals that trigger regeneration in surrounding tissues. These signals attract stem cells and progenitor cells to the area, stimulating them to divide and produce fresh replacements. The dying cells are essentially calling for their own successors, ensuring a smooth transition that maintains tissue function without interruption. This signaling system allows tissues to anticipate their own renewal needs, rather than waiting for catastrophic failure. The signals also coordinate the timing of replacement, ensuring that new cells mature and integrate properly before old cells are fully cleared away. Death and birth are thus linked in an elegant communication network that keeps tissues perpetually youthful. The old cells serve the future, even as they fade away. Stem cells wait in the body like seeds in the soil. Scattered throughout your adult body are reservoirs of stem cells that remain in a dormant state, waiting for signals that awaken them to action. These cells reside in protected niches within bone marrow, muscle tissue, skin, and many other organs, maintaining their potential to become various cell types. When injury occurs or tissues need renewal, chemical signals reach these dormant populations and trigger them to divide and differentiate into the specific cell types required. Like seeds lying dormant through winter, these stem cells can remain inactive for years until conditions are right for germination. The niches that house them provide protection from the stresses that might cause premature activation or exhaustion. This reserve capacity ensures that the body maintains its regenerative potential throughout life. Even in old age, these cellular seeds retain their power to sprout new growth. Old cells can be reprogrammed back toward youth. Scientists have discovered that aged cells can be rejuvenated by activating certain genes that are normally active only in embryonic development. This reprogramming can reset the molecular clocks within cells, erasing the accumulated damage and dysfunction of aging and restoring youthful function. The discovery has profound implications for regenerative medicine and the treatment of age-related diseases. In laboratory experiments, reprogrammed cells show renewed capacity for division, improved energy production, and enhanced repair capabilities. The process suggests that aging is not an inevitable one-way journey, but a potentially reversible state. While complete rejuvenation remains a distant goal, partial reprogramming offers hope for extending healthy lifespan and treating conditions once thought incurable. The body carries within it the instructions for its own renewal, waiting to be reawakened. Platelets are the first responders of the bloodstream. Within seconds of an injury that breaks the skin, tiny cell fragments called platelets rush to the scene of the wound. These disc-shaped particles circulate constantly in your blood, ready to spring into action at the first sign of damage. When they encounter exposed collagen from damaged blood vessel walls, they immediately become sticky and begin clumping together to form a plug that stops the bleeding. Platelets also release chemical signals that summon more platelets to the area and activate the clotting cascade. This initial response happens so quickly that most small cuts stop bleeding before you even notice them. Without platelets, even minor injuries would result in dangerous blood loss. They are the emergency services of your circulatory system, always on patrol and ready to respond in an instant. Blood carries tiny messengers that call for repair crews. When tissue is damaged, your blood becomes a communication highway, carrying molecular messages that coordinate the entire healing response. Growth factors, cytokines, and other signaling molecules are released from damaged cells and activated platelets, spreading through the bloodstream and surrounding tissues. These chemical messengers recruit immune cells to fight infection, summon fibroblasts to rebuild tissue, and stimulate the growth of new blood vessels to supply the healing area. The signaling is precisely timed, with different factors appearing in sequence to orchestrate each phase of healing. Too little signaling results in incomplete healing, while too much can cause excessive inflammation or scarring. The blood carries not just nutrients and oxygen, but an entire postal system of chemical instructions. Every wound triggers a cascade of messages that coordinate the complex dance of repair. New blood vessels sprout like roots in a healing wound. As a wound begins to heal, the surrounding tissue desperately needs increased blood supply to fuel the energy-intensive repair process. In response, existing blood vessels near the wound edge begin sprouting new branches that grow toward the center of the damaged area. This process, called angiogenesis, is guided by chemical signals from the wound that act like beacons, drawing the new vessels forward. The sprouting vessels are led by specialized tip cells that extend finger-like projections to sense the chemical gradient and find the best path. Behind them, stalk cells multiply and form the tubes that will carry blood. Within days, a network of tiny capillaries laces through the healing tissue, providing oxygen and nutrients for repair. These new vessels give fresh wounds their characteristically pink or red color as healing progresses. Skin cells crawl across wounds to rejoin edges. The closure of a wound depends on the remarkable ability of skin cells to uproot themselves and migrate across the wound surface. Normally, skin cells are tightly anchored to their neighbors and the underlying tissue, but after injury, cells at the wound edge loosen these connections and begin crawling toward the center. They flatten and extend thin projections that grip the wound bed and pull the cell body forward. Multiple cells move together like a coordinated sheet, covering the wound with a thin layer of new epithelium. This migration continues until cells from opposite edges meet in the middle and recognize each other, triggering them to stop moving and re-establish permanent connections. The entire process is guided by electrical fields that naturally arise at wound edges. Skin cells navigate toward the wound center as if following an invisible map. Fibroblasts weave collagen like biological thread. Beneath the surface of a healing wound, specialized cells called fibroblasts work tirelessly to rebuild the structural framework of the skin. These cells produce collagen, a tough protein fiber that provides strength and elasticity to tissues. Fibroblasts secrete collagen molecules that spontaneously assemble into fibers outside the cell, forming a dense mesh that fills the wound space. The fibers are laid down in organized patterns that give the new tissue its mechanical properties. Fibroblasts also produce other matrix proteins and ground substances that help organize the collagen and provide scaffolding for other cells. As healing progresses, the collagen network is continuously remodeled, with fibers being broken down and replaced to improve the strength and alignment of the scar. The weaving continues for months after the wound has closed, gradually refining the repair. Scars are collagen's way of patching the past. When the body repairs deep wounds, it often sacrifices perfect restoration for speed, filling the gap with dense collagen that differs from the original tissue architecture. Scar tissue lacks the complexity of normal skin, missing hair follicles, sweat glands, and the precise organization of collagen fibers that give healthy skin its flexibility. The collagen in scars is laid down in parallel bundles, rather than the basket weave pattern of undamaged skin, making it stiffer and less elastic. Scars may fade over time as the collagen is slowly remodeled, but they rarely disappear completely. The trade-off makes biological sense, as rapid wound closure prevents infection and blood loss, even if the repair is imperfect. Scars are the body's compromise between ideal restoration and practical necessity. They are records of healing written in collagen. Some people's skin can heal without leaving scars at all. While most adults form scars after significant injury, some remarkable exceptions challenge our understanding of wound healing. Babies in the womb can heal wounds without any scarring at all, as their developing skin uses different molecular pathways than adult tissue. Some adults retain this ability to varying degrees, healing with minimal or no visible scarring due to genetic differences in their inflammatory response. Scientists studying these individuals hope to unlock the secrets of scarless healing for everyone. Research has already identified key differences in the behavior of immune cells and fibroblasts that distinguish scarring from regenerative healing. The goal is to develop treatments that could redirect adult wound healing toward the fetal pattern. The possibility of scarless healing suggests that our bodies possess latent regenerative abilities that might be reawakened. The immune system remembers every battle it has fought. Your immune system maintains an extraordinary archive of every pathogen it has ever encountered, allowing it to respond faster and more effectively to repeated threats. This immunological memory is carried by specialized cells called memory B cells and memory T cells, which can persist in the body for decades. When a familiar invader returns, these memory cells recognize it immediately and mount a rapid response that often eliminates the threat before you ever feel ill. This is why childhood illnesses rarely strike twice, and why vaccines can provide lasting protection. The memory is remarkably specific, able to distinguish between thousands of different pathogens, and remember each one individually. Some memory cells patrol the bloodstream, while others reside in tissues where infections are most likely to occur. Your immune system is not just a defensive force, but a living library of past battles. Fever is the body's cleansing fire. When infection strikes, the body often responds by raising its internal temperature, creating conditions that favor immune function while hindering pathogen survival. Many bacteria and viruses replicate more slowly at elevated temperatures, giving the immune system a crucial advantage. Fever also accelerates the metabolic rate of immune cells, allowing them to divide faster and produce antibodies more quickly. The heat triggers the production of heat shock proteins that help cells survive stress and may enhance immune signaling. While uncomfortable, moderate fever is generally beneficial and represents an active choice by the body to sacrifice comfort for survival. The hypothalamus acts as the thermostat, resetting the body's target temperature in response to signals from immune cells. Fever is not a malfunction but a carefully calibrated weapon in the body's defensive arsenal. White blood cells communicate with faint pulses of light. In a discovery that sounds almost magical, scientists have found that certain white blood cells emit extremely faint pulses of light as part of their communication system. These biophotons are produced during metabolic processes and may carry information between cells in ways that complement chemical signaling. Neutrophils, the most abundant type of white blood cell, produce bursts of light when they attack pathogens, and this light may signal to other immune cells in the vicinity. The phenomenon is so subtle that it requires extremely sensitive detection equipment to observe, but it appears to be a genuine form of cellular communication. Some researchers believe that biophoton signaling could coordinate immune responses across large areas of tissue. The discovery adds another layer of wonder to our understanding of how the body defends itself. Light and life are intertwined in ways we are only beginning to appreciate. Macrophages switch roles once the battle is won. Macrophages are versatile immune cells that can dramatically change their behavior depending on the signals they receive from their environment. During active infection, they adopt an aggressive pro-inflammatory state, engulfing pathogens and releasing toxic chemicals to kill invaders. But once the threat is neutralized, these same cells can switch to a healing-promoting state that supports tissue repair and dampens inflammation. This transformation is controlled by signals from other immune cells and from the damaged tissue itself. The ability to switch roles makes macrophages essential for both phases of the healing process, ensuring that the transition from defense to repair happens smoothly. Without this flexibility, the body would struggle to end the inflammatory response and begin rebuilding. Macrophages are both warriors and healers, adapting their nature to serve whatever role the body needs most. Inflammation is both destruction and the beginning of repair. The redness, swelling, and pain of inflammation are often seen as problems to be suppressed, but they represent essential steps in the healing process. Inflammation brings blood and immune cells to the site of damage, clears away debris and dead tissue, and creates conditions that support repair. The increased blood flow delivers oxygen and nutrients while removing waste products. Swelling creates space for immune cells to work and prevents the spread of infection. Pain signals discourage use of the injured area, allowing healing to proceed undisturbed. Without inflammation, wounds would become infected and healing would stall. The key is that inflammation must be carefully controlled, intense enough to do its job, but limited in duration to prevent tissue damage. Inflammation is not the enemy of healing, but its essential opening act. The body knows how to shut down inflammation after healing. Just as the body can initiate inflammation when needed, it possesses sophisticated mechanisms to resolve inflammation once healing is underway. Specialized molecules called resolvins, protectins, and maresins actively promote the resolution of inflammation rather than simply blocking it. These signals tell immune cells to stop releasing pro-inflammatory chemicals and begin producing anti-inflammatory ones. They also promote the clearance of dead cells and debris that might otherwise perpetuate the inflammatory response. The transition from inflammation to resolution is carefully timed, ensuring that the defensive phase lasts long enough to eliminate threats, but not so long that it damages healthy tissue. Failure to resolve inflammation properly can lead to chronic inflammatory conditions that cause ongoing tissue damage. The body's ability to know when enough is enough reflects millions of years of evolutionary refinement. Nerves can find their way back by following chemical trails. When peripheral nerves are damaged, they possess a remarkable ability to regrow and find their original targets by following chemical signals left behind in the surrounding tissue. The severed nerve stump produces growth cones, specialized structures that extend finger-like projections to sense the chemical environment and navigate toward their destination. Schwann cells, which normally wrap around nerve fibers to provide insulation, create tubes that guide the regrowing nerve along its original path. These cells also release growth factors that encourage regeneration and provide physical scaffolding for the new nerve tissue. The process is slow, with nerves growing only a few millimeters per day, but remarkably accurate in finding the correct target. This is why feeling and function often return gradually after nerve injuries. The chemical trails are like breadcrumbs leading the lost nerve back home. The brain can rewire itself after injury. For decades, scientists believed the adult brain was fixed and unchangeable, but we now know it possesses remarkable plasticity that allows it to reorganize after damage. When one brain region is injured, other areas can take over its functions through the strengthening of existing connections and the formation of new ones. Stroke survivors can regain lost abilities as undamaged brain regions learn to perform tasks they never handled before. This rewiring is driven by repeated practice and experience, which strengthens new neural pathways. The process requires immense effort and time, but the results can be astonishing. People who have lost the use of limbs can learn to control them again as the brain remaps itself. Neuroplasticity reveals that the brain is not a static organ but a dynamic system constantly reshaping itself in response to experience and need. Memories can be rewritten through emotional healing. The brain does not store memories like a computer, but reconstructs them each time they are recalled, and this reconstruction process offers an opportunity for healing. When traumatic memories are retrieved in a safe environment, they can be updated with new emotional associations that reduce their power to cause distress. This is the principle behind many forms of therapy, where revisiting painful experiences with support allows the brain to reprocess them. The memory itself is not erased, but its emotional charge can be significantly reduced. Research has shown that the reconsolidation window after memory retrieval is when the memory is most malleable and open to change. This means that healing does not require forgetting, but rather changing how memories are stored and experienced. The past cannot be changed, but our relationship to it can be transformed. The brain's immune cells help clear away dead neurons. The brain has its own specialized immune system, separate from the rest of the body, that plays a crucial role in healing after injury. Microglial cells are the brain's resident immune cells, and they act as both defenders and cleanup crews. When neurons die from injury or disease, microglia migrate to the affected area and engulf the debris, clearing away dead tissue that might otherwise trigger harmful inflammation. They also release growth factors that support surviving neurons and promote repair. This cleaning function is essential because accumulated debris can interfere with the formation of new connections and perpetuate damage. Microglia can recognize subtle signals from stressed or dying neurons and respond before damage spreads. They are the unsung custodians of the brain, maintaining the environment that allows healing to occur. Microglia rebuild synaptic connections after trauma. Beyond their role in clearing debris, microglia actively participate in rebuilding the brain's communication networks after injury. They help prune away damaged synapses and promote the formation of new connections between surviving neurons. This synaptic remodeling is essential for functional recovery, as the brain's power comes from the patterns of connections between cells, rather than the cells themselves. Microglia release chemicals that encourage neurons to sprout new branches and form new synapses. They also help regulate the balance between excitation and inhibition that keeps brain circuits functioning properly. Research has shown that manipulating microglial function can enhance recovery from brain injuries. These versatile cells are both demolition crews and construction workers, tearing down what is broken and helping to build what comes next. The blood-brain barrier can repair itself after damage. The blood-brain barrier is a selective filter that protects the brain from potentially harmful substances in the bloodstream, while allowing essential nutrients to pass through. When this barrier is breached by injury, infection, or stroke, the brain becomes vulnerable to inflammation and toxicity. Remarkably, the barrier has built-in repair mechanisms that can restore its integrity after damage. Endothelial cells that form the barrier's walls can divide and migrate to seal gaps. Astrocytes, star-shaped support cells, extend their feet to reinforce the barrier and release signals that promote healing. The repair process is coordinated with the resolution of inflammation in the surrounding brain tissue. While severe or repeated damage can overwhelm these repair mechanisms, the barrier demonstrates impressive resilience in recovering from minor insults. This self-healing capacity protects the brain from the consequences of everyday bumps and minor injuries. Chronic pain can be retrained out of the nervous system. Chronic pain is often not a sign of ongoing tissue damage, but a learned pattern in the nervous system that has become self-perpetuating. The brain and spinal cord can become sensitized, amplifying pain signals even when the original injury has healed. Fortunately, the same plasticity that allows the nervous system to learn pain also allows it to unlearn it. Pain reprocessing therapy and graded motor imagery are techniques that help retrain the brain to interpret signals differently. By gradually exposing patients to movements and activities they fear, while teaching them that these activities are safe, the nervous system can recalibrate its responses. Success requires patience and persistence, but many people with chronic pain have achieved significant relief through these approaches. The brain that learned to generate pain can learn to let it go. The heart can regrow a small portion of its own tissue. For many years, scientists believed the heart was incapable of regeneration, that the muscle cells you were born with were the only ones you would ever have. Recent research has overturned this view, revealing that the heart does possess limited regenerative capacity. About 1% of heart muscle cells are replaced each year in young adults, a rate that declines with age. While this regeneration is too slow to repair major damage like a heart attack, it demonstrates that the heart is not as static as once thought. Scientists are working to understand what limits this regeneration and whether it can be enhanced. Some species, like zebrafish and newborn mice, can fully regenerate their hearts after injury, suggesting the genetic potential exists, but is somehow suppressed in adult mammals. The discovery opens new possibilities for treating heart disease by awakening the heart's dormant regenerative powers. Your heart creates new cells throughout your life. Using clever techniques involving radioactive carbon dating from nuclear tests, scientists have proven that the human heart continues to produce new muscle cells throughout life. The rate of cell turnover is highest in youth and decreases with age, but it never stops entirely. By age 75, about half of the heart's muscle cells have been replaced since birth. This ongoing renewal means the heart you have today is not exactly the same heart you were born with, even though much of its original structure remains. The new cells integrate seamlessly with the old, maintaining the rhythmic contraction that keeps blood flowing. Understanding how the heart produces these new cells could lead to treatments that boost regeneration after injury. The heart beats on, quietly renewing itself with each passing year. The heart can form new vessels after blockage. When coronary arteries become blocked, limiting blood flow to the heart muscle, the body can respond by growing new blood vessels to bypass the obstruction. This process, called arteriogenesis, involves the enlargement of small existing vessels to carry more blood and the sprouting of entirely new capillaries. The growth is triggered by signals from oxygen-starved tissue and by the increased flow through alternative pathways. Regular exercise can enhance this natural bypass process, encouraging the growth of collateral vessels before a crisis occurs. The new vessels may never fully replace a major blocked artery, but they can significantly improve blood supply and reduce the damage from a heart attack. This remarkable adaptability demonstrates the cardiovascular system's resilience and its ability to find alternative routes when the main roads are blocked. Collateral circulation acts like a natural bypass. The network of small blood vessels that can expand to bypass blocked arteries is called collateral circulation, and it represents one of the heart's most important self-protective mechanisms. These alternative pathways exist in everyone, but vary greatly in their development and effectiveness. In people with gradually developing coronary disease, collateral vessels have time to enlarge and can sometimes maintain adequate blood flow even when major arteries are severely blocked. This is why some people can tolerate heart attacks that would be fatal for others. The growth of collaterals can be encouraged through regular cardiovascular exercise, which creates the stress signals that stimulate vessel growth. Medications that promote angiogenesis are being developed to enhance this natural bypass system. The body's ability to reroute blood flow shows its remarkable engineering for survival. Scar tissue in the heart can remodel over time. After a heart attack kills a portion of heart muscle, scar tissue forms to maintain the structural integrity of the organ. This scar tissue does not contract like normal heart muscle and can impair the heart's pumping function. However, the scar is not static but continues to remodel for months and even years after the initial injury. Over time, the scar becomes more compact and organized, and the surrounding healthy tissue adapts to compensate for the lost function. Physical rehabilitation and proper medication can enhance this remodeling process and improve outcomes. In some cases, the heart's function improves significantly in the year following a heart attack as remodeling progresses. While the dead muscle cannot be brought back, the heart learns to work with what remains. Healing continues long after the acute event has passed. Capillaries grow toward oxygen-starved tissue. Tissues that are deprived of adequate oxygen release distress signals that stimulate the growth of new capillaries to restore blood supply. This process, called angiogenesis, is essential for healing and adaptation throughout the body. vascular endothelial growth factor and other signaling molecules create a chemical gradient that guides sprouting vessels toward the areas of greatest need. The new capillaries bring not only oxygen but also nutrients, immune cells and growth factors that support repair. This oxygen-seeking behavior of blood vessels ensures that healing tissue receives priority access to resources. The process also allows muscles and other tissues to adapt to increased demands by growing additional blood supply. When you exercise regularly, your muscles become more richly supplied with capillaries, improving their performance and endurance. The circulatory system continuously reshapes itself to meet the body's changing needs. Sleep is when most cellular healing actually happens. While we often think of rest as passive, sleep is actually when the body shifts into its most active repair mode. During deep sleep stages, blood pressure drops, breathing slows, and muscles relax, allowing blood flow to increase to tissues that need repair. Energy that would normally be devoted to movement, digestion, and conscious thought is redirected toward healing processes. Proteins required for cell growth and tissue repair are synthesized primarily during sleep. The immune system becomes more active, with increased production of infection-fighting cells and antibodies. Studies have shown that people who are sleep-deprived heal from wounds more slowly and are more susceptible to illness. Sleep is not merely the absence of wakefulness, but a specialized state, optimized for restoration. The body knows that darkness is the time to rebuild. The brain releases endorphins during healing sleep. During restorative sleep, the brain produces elevated levels of endorphins, the body's natural pain-relieving and mood-enhancing chemicals. These molecules reduce the perception of pain, allowing the body to rest more deeply and heal more effectively. Endorphins also create feelings of calm and well-being that support the relaxation necessary for deep sleep. The release is particularly pronounced during the deeper stages of sleep, when tissue repair is most active. This connection between pain relief and sleep explains why adequate rest is so important for recovery from injury or surgery. Disrupted sleep patterns can lead to increased pain sensitivity and slower healing. The brain orchestrates a nightly gift of natural medicine that soothes the body as it repairs. Sleep is its own kind of painless healing. Growth hormone surges during deep rest. The largest release of growth hormone in adults occurs during the first few hours of deep sleep each night. This hormone is essential for tissue repair, muscle growth, and the regeneration of cells throughout the body. It stimulates the liver to produce insulin-like growth factor, which promotes healing in virtually every tissue. In children, growth hormone is responsible for physical development, but in adults it continues to play a vital role in maintenance and repair. Sleep deprivation can reduce growth hormone secretion by as much as 70%, significantly impairing the body's regenerative capacity. The timing of sleep also matters, as the hormone surge is linked to circadian rhythms and sleep cycles. Going to bed at consistent times helps optimize this nightly repair signal. The body grows and heals in the quiet hours of sleep. The brain performs nightly housekeeping during sleep. During sleep, the brain initiates a remarkable cleaning process that removes toxic waste products accumulated during waking hours. The glymphatic system, a network of channels that runs alongside blood vessels, expands during sleep to flush out cellular debris and metabolic waste. This includes beta amyloid, a protein associated with Alzheimer's disease, which is cleared from the brain much more efficiently during sleep than during wakefulness. The cleaning process requires the brain to enter specific sleep states, particularly deep, slow-wave sleep. Without adequate sleep, waste products accumulate and can impair brain function over time. This nightly housekeeping is essential for maintaining cognitive health and preventing neurodegenerative conditions. The brain washes itself clean each night while you rest. Sleep is the time when the mind takes out the rubbish. Wounds heal faster when the body's clock is in sync. The body's circadian rhythm profoundly influences healing, with research showing that wounds sustained during the day heal significantly faster than those occurring at night. This is because the cells responsible for wound healing are more active during waking hours, when injuries are most likely to occur. The skin's fibroblasts migrate more quickly during daytime, and the immune response is more robust. Studies on burn victims found that injuries occurring during the day healed about 11 days faster than those occurring at night. This circadian timing affects not just wound healing but recovery from surgery as well. Scheduling operations during times when the body is optimized for repair could improve outcomes. The body has evolved to anticipate when damage is most likely and prepares accordingly. Healing follows the rhythm of the sun. Each organ has its own daily schedule of renewal. The body's organs do not all repair themselves at the same time, but follow distinct circadian schedules that optimize regeneration while minimizing interference with normal function. The liver is most active in detoxification and repair during the late evening. The stomach lining regenerates primarily overnight when digestion is minimal. Muscles recover most effectively during the early hours of sleep. Bone formation peaks in the early morning. These schedules are coordinated by the master clock in the brain's hypothalamus, which synchronizes the peripheral clocks in each organ. Disrupting these rhythms through shift work, jet lag, or irregular sleep can impair the body's regenerative capacity. Understanding these schedules could allow medical treatments to be timed for maximum effectiveness. The body is a symphony of clocks, each playing its part in the rhythm of renewal. Sunlight helps trigger the body's natural healing rhythms. Exposure to natural daylight is essential for maintaining the circadian rhythms that govern healing throughout the body. Light entering the eyes signals the brain's master clock to synchronize all the peripheral clocks that control when tissues repair and regenerate. Morning light exposure is particularly important for setting these rhythms correctly, helping to optimize sleep quality and the release of growth hormone at night. Sunlight also triggers the production of vitamin D in the skin, a hormone that plays crucial roles in immune function and bone health. Patients in hospital rooms with windows facing the sun have been shown to recover faster than those in darker rooms. The absence of natural light disrupts circadian rhythms and can impair wound healing and immune function. Light is not just for seeing but for healing. The body evolved under the sun and continues to depend on its rhythms. Blue light can help heal certain skin conditions. Specific wavelengths of blue light have been found to have therapeutic effects on certain skin conditions, particularly those caused by bacteria. Blue light at wavelengths around 415 nanometers can kill the bacteria that cause acne without damaging surrounding skin cells. The light activates compounds produced by the bacteria themselves, generating reactive oxygen species that destroy the microorganisms from within. This phototherapy approach offers an alternative to antibiotics for treating skin infections. Blue light has also been used to treat neonatal jaundice, where it helps break down bilirubin in newborn babies' blood. The healing power of specific light wavelengths was largely overlooked until recent decades, when research began to reveal how precisely the body responds to different colors of light. Light is both energy and information, carrying healing messages to cells. Red light stimulates collagen and tissue repair. Near-infrared and red light wavelengths penetrate deep into tissues and have been shown to stimulate cellular repair processes at the molecular level. These wavelengths are absorbed by mitochondria, the energy-producing structures within cells, enhancing their ability to generate the fuel that powers healing. Red light therapy has been shown to accelerate wound healing, reduce inflammation, and stimulate the production of collagen in skin. The treatment is now used for conditions ranging from chronic wounds to sports injuries to skin rejuvenation. Unlike ultraviolet light, which can damage tissues, red and near-infrared wavelengths appear to support cellular function without harmful effects. The discovery has led to the development of light-based therapies used in clinics around the world. Cells respond to gentle red light as if it were an encouraging signal to work harder. Healing can be enhanced by simply shining the right light on damaged tissue. Astronauts use red light to help tissue recovery in space. In the microgravity environment of space, astronauts face numerous challenges, including slower wound healing and muscle atrophy. NASA has investigated the use of red light-emitting diodes to counter these effects, with promising results. Studies on the International Space Station have shown that red light therapy can accelerate the healing of injuries sustained in space. The technology was originally developed to grow plants in space, but was found to have unexpected benefits for human tissue repair. Light therapy devices are now part of the medical toolkit available to astronauts on long-duration missions. The research has also benefited medicine on Earth, leading to new treatments for wounds, burns, and musculoskeletal injuries. The vacuum of space has become an unexpected laboratory for understanding how light affects human healing. What works in orbit often works even better on the ground. Cells whisper to each other using electromagnetic fields. Beyond the chemical signals that coordinate healing, cells also communicate through subtle electromagnetic fields that carry information across tissues. Every cell generates tiny electrical currents as ions flow across its membrane, creating fields that neighboring cells can detect. These bioelectric signals play roles in wound healing, where natural electrical currents arise at wound edges and guide cells toward the site of injury. Research has shown that enhancing these natural currents can accelerate healing, while blocking them can impair recovery. Some cells may also communicate through ultra-weak photon emissions, essentially whispering to each other with light too faint for human eyes to see. The electromagnetic conversation between cells adds another layer of coordination to the already complex symphony of healing. The body speaks in frequencies we are only beginning to hear and understand. Stress can quietly slow the body's repair process. When the body is under psychological stress, it diverts resources away from long-term maintenance toward immediate survival needs. The stress response evolved to help us escape physical dangers, but it also suppresses functions that are not essential in an emergency, including tissue repair and immune defense. Cortisol, the primary stress hormone, inhibits the production of growth factors and pro-inflammatory signals that are necessary for wound healing. Studies have shown that stressed individuals heal from wounds significantly more slowly than those who are relaxed. Even the stress of caring for an ill relative has been shown to delay wound healing by days. The effect is not imaginary but measurable in the speed of tissue regeneration and the strength of immune responses. Stress whispers to the body that danger is near and healing can wait. Learning to manage stress is itself a form of medicine. Chronic stress suppresses the immune response. While acute stress can temporarily boost certain immune functions, prolonged chronic stress has the opposite effect, gradually weakening the body's defenses. Elevated cortisol levels over extended periods suppress the production and activity of immune cells, leaving the body more vulnerable to infections. Chronic stress also shifts the immune system toward a pro-inflammatory state that damages tissues while failing to effectively fight pathogens. People under chronic stress get sick more often, take longer to recover, and respond less effectively to vaccines. The suppression affects virtually every branch of the immune system, from antibody production to natural killer cell activity. This explains why stressful life events are often followed by illness. The immune system cannot remain on high alert forever, and eventually becomes exhausted. Managing chronic stress is essential for maintaining the body's capacity to heal and defend itself. Your blood changes its chemistry during emotional stress. Emotional states are not confined to the mind, but are reflected in measurable changes throughout the body, including the composition of the blood itself. During stress, the adrenal glands release cortisol and adrenaline, which circulate through the bloodstream and affect virtually every organ. Stress hormones cause blood sugar to rise, blood pressure to increase, and clotting factors to become more active. Inflammatory markers increase, while markers associated with tissue repair decrease. The blood becomes primed for emergency action, rather than routine maintenance. These changes can be detected with simple blood tests, and have been shown to correlate with healing outcomes. Even brief periods of acute stress can alter blood chemistry for hours afterward. The blood is a mirror of our emotional state, carrying the signature of our stress to every cell in the body. What we feel, our blood reveals. Hope can shift hormone levels toward regeneration. The emotional state of hope is not merely a pleasant feeling, but triggers measurable physiological changes that support healing. When people feel hopeful about their recovery, their bodies produce different patterns of hormones than when they feel hopeless or despairing. Hopeful states are associated with lower cortisol levels, higher growth hormone levels, and increased activity in neural pathways associated with reward and motivation. These changes create an internal environment that favors tissue repair and immune function. Studies have shown that patients who maintain hope during illness often have better outcomes than those who surrender to despair. The effect appears to be mediated by the complex connections between the brain's emotional centers and the endocrine and immune systems. Hope is not wishful thinking, but a physiological state that changes the body's chemistry. The mind's belief in recovery helps create the conditions for recovery to occur. Optimism can lower inflammation markers in the blood. Research has found consistent associations between optimistic personality traits and lower levels of inflammatory markers in the bloodstream. Optimists tend to have lower levels of C-reactive protein, interleukin-6, and other molecules associated with chronic inflammation. This matters because chronic low-grade inflammation is linked to numerous diseases of aging, including heart disease, diabetes, and cognitive decline. The mechanism appears to involve optimists, healthier behaviors, better stress management, and stronger social connections, all of which reduce inflammatory burden. But beyond these factors, optimism itself seems to have direct effects on immune function. Optimistic people recover faster from surgery, heal wounds more quickly, and live longer on average. The mind's stance toward the future influences the body's state in the present. Choosing to expect good outcomes may be one of the most healing choices we can make. Emotions influence how quickly a wound closes. Experiments have demonstrated that emotional states directly affect the speed of wound healing in ways that cannot be explained by behavior alone. In one study, couples who discussed conflicts healed from small skin wounds more slowly than when they had supportive conversations. The wounds took up to 2 days longer to close after hostile interactions. The effect was linked to changes in cytokine levels at the wound site, with hostile couples showing higher levels of inflammatory markers that impede healing. Similar effects have been observed in studies of caregivers, students during exams, and people experiencing various life stressors. The emotional climate of our lives writes itself into the speed of our recovery. This connection between feelings and flesh reveals how deeply intertwined mind and body truly are. Emotional well-being is not separate from physical healing but woven into its very fabric. Laughter changes hormones that support healing. When you laugh, your body undergoes a cascade of hormonal changes that create conditions favorable for healing. Laughter reduces cortisol and adrenaline, the stress hormones that suppress immune function and tissue repair. At the same time, it increases the production of endorphins, dopamine, and serotonin, creating feelings of pleasure and relaxation that support recovery. Studies have shown that even anticipating a funny event can begin to shift hormone levels in beneficial directions. The hormonal changes from laughter can persist for hours after the laughter itself has ended. Patients who watch comedies have been shown to have lower stress hormone levels and better immune function than those who watch neutral programs. Laughter is not just a response to joy, but a creator of the physiological conditions that promote it. The body heals better when it has something to laugh about. Laughter boosts circulation and immune function. The physical act of laughing involves the contraction of muscles throughout the body, including the diaphragm, abdominal muscles, and even the heart. This muscular workout increases heart rate and blood pressure temporarily, followed by a relaxation phase with decreased heart rate and muscle tension. The effect is similar to mild exercise and improves blood circulation throughout the body. Laughter has also been shown to increase the activity of natural killer cells and other immune cells that protect against infection and cancer. The enhancement of immune function can last for hours after a bout of hearty laughter. Researchers found that people who laugh frequently have stronger immune responses to vaccines and faster recovery from illness. The body responds to laughter as if it were a form of gentle exercise, with many of the same health benefits. Joy ripples through the body long after the joke has passed. Tears contain enzymes that protect against infection. Tears are far more than salty water flowing from the eyes. They contain lysozyme, an enzyme that can destroy the cell walls of bacteria, providing a first line of defense against eye infections. Emotional tears, shed in response to sadness or joy, have a different composition than reflex tears triggered by irritants, containing higher levels of stress hormones and other proteins. Some researchers believe that emotional crying serves to expel stress chemicals from the body, providing a physical release of tension. The act of crying also stimulates the parasympathetic nervous system, promoting relaxation and recovery after emotional upheaval. Cultures that permit crying tend to have better outcomes in grief and trauma recovery than those that suppress it. Tears are the body's way of washing away both physical threats and emotional burdens. They are a form of healing that needs no medicine. Gratitude changes the heart's electrical patterns. Research using heart rate variability measurements has shown that feelings of gratitude and appreciation create more coherent and ordered patterns of heart rhythm. This state, called cardiac coherence, is associated with reduced stress, improved immune function, and enhanced mental clarity. The heart generates the strongest electromagnetic field in the body, and this field changes measurably when people experience sincere feelings of gratitude. The coherent heart patterns send signals to the brain that reinforce positive emotional states, creating a feedback loop between heart and mind. Practicing gratitude has been shown to lower blood pressure, improve sleep quality, and reduce symptoms of depression. The heart is not just a pump, but a sophisticated organ that responds to and generates emotional states. Feeling grateful literally changes the rhythm of your heartbeat. Gratitude activates brain regions linked to regeneration. Neuroimaging studies have revealed that experiencing gratitude activates brain regions associated with reward, social bonding, and the regulation of stress. The hypothalamus, which controls many aspects of metabolism and healing, shows increased activity during gratitude experiences. The anterior cingulate cortex and medial prefrontal cortex, regions involved in regulating emotion and stress response, also light up when people feel grateful. This neural activity is associated with the release of dopamine and serotonin, neurotransmitters that promote well-being and are linked to healing processes. Regular gratitude practice has been shown to strengthen these neural pathways, making positive states easier to access over time. The brain responds to gratitude as if it were receiving a reward, reinforcing the behavior and its associated benefits. Training the mind toward appreciation may be one of the simplest and most powerful ways to support the body's healing. Gratitude is medicine that the brain prescribes to itself. Chronic loneliness can suppress the body's healing. Loneliness is not merely an unpleasant emotion, but a physiological state that affects the body's ability to heal and defend itself. People who experience chronic loneliness show elevated levels of stress hormones, increased inflammation, and suppressed immune function. Their wounds heal more slowly, they are more susceptible to infection, and they have higher rates of cardiovascular disease and cognitive decline. The effects are comparable to those of smoking or obesity in terms of impact on health and longevity. Loneliness triggers the same biological alarm systems as physical threat, keeping the body in a state of vigilance that exhausts its resources. The brain interprets social isolation as a survival risk and responds by preparing for danger rather than repair. Humans evolved as deeply social creatures, and our bodies depend on connection for their well-being. Healing happens best when we are not alone. Love literally strengthens the immune system. The experience of being loved and cared for creates measurable changes in immune function that enhance the body's ability to fight infection and heal from injury. People in loving relationships have higher levels of natural killer cells and stronger antibody responses to vaccines. They recover faster from surgery and have lower rates of chronic illness. The effects appear to be mediated by reduced stress, better sleep, and the direct effects of touch and emotional connection on hormone levels. Even the perception of being loved, regardless of the objective circumstances, confers health benefits. Love changes the chemistry of the body, shifting it toward states that favor regeneration and repair. The heart that loves is also the heart that heals. Connection is not a luxury, but a biological necessity. Touch between friends reduces blood pressure. Physical contact between people who care for each other triggers the release of oxytocin and reduces the activity of the stress response system. Even a brief touch from a friend can lower blood pressure, reduce heart rate, and decrease cortisol levels. The effect is not limited to romantic partners, but extends to any relationship characterized by trust and affection. Holding hands with a loved one has been shown to reduce the brain's response to threatening stimuli. The skin is rich with nerve endings that respond to gentle touch by sending calming signals to the brain. Regular physical contact helps maintain lower baseline levels of stress hormones, creating conditions that favor long-term health. Touch is the most ancient form of communication and carries deep healing power. The body knows the difference between isolation and connection. Infants heal faster when held close. Premature babies who receive regular skin-to-skin contact with their parents, a practice called kangaroo care, show faster weight gain, more stable vital signs, and shorter hospital stays. The warmth, touch, and sound of a parent's heartbeat create an optimal environment for development and healing. Even full-term newborns who are held frequently cry less, sleep better, and show stronger immune function. The effects persist beyond infancy, with early touch experiences influencing stress responses and health outcomes throughout life. The infant's body is designed to expect close contact and develops best when that expectation is met. Separation from caregivers triggers stress responses that divert energy from growth and repair toward survival. Holding a baby is not indulgence but medicine. The warmth of human contact is among the first and most powerful healers. Pain can lessen when someone simply listens. The experience of being heard and understood can reduce the perception of pain, even without any physical intervention. When people feel their suffering is witnessed and validated, their stress response decreases, and their pain tolerance increases. Studies have shown that patients who feel their healthcare providers truly listen to them report less pain and better outcomes. The mechanism appears to involve the activation of brain regions associated with social connection, which modulate the same neural pathways that process pain. Feeling alone in one's suffering amplifies it, while feeling accompanied diminishes it. This is why companionship has always been part of healing rituals across cultures. Words of comfort are not merely symbolic but physiologically active. Sometimes the most healing thing we can offer is simply our attention. Empathy activates the same brain regions as pain relief. When someone shows genuine empathy toward a person in pain, the brain of the suffering individual shows activation patterns similar to those produced by pain-relieving medications. The empathic presence of another person seems to engage the brain's internal opioid system, reducing pain perception through natural mechanisms. Conversely, feeling that one's pain is dismissed or minimized can increase pain sensitivity. Healthcare providers who demonstrate warmth and empathy tend to have patients who heal faster and require less pain medication. The brain evolved to expect social support during times of distress and responds to its presence with relief. Empathy is not just emotionally comforting, but neurologically analgesic. The caring attention of another person is itself a form of medicine. Singing together synchronizes breathing and heartbeats. When people sing together in a choir or group, their breathing patterns naturally synchronize as they follow the same phrases and rhythms. Remarkably, this synchronization extends to the heartbeat, with singers' heart rates rising and falling in unison. This physiological entrainment creates a sense of connection and shared experience that transcends words. Group singing has been shown to reduce cortisol levels, increase oxytocin, and boost immune function. The act of singing together has been used in healing rituals across cultures for thousands of years. Modern research confirms what traditional societies intuited, that collective music making has profound effects on mind and body. The vibrations of shared song create a bond that resonates through every cell. When we sing together, our bodies literally come into harmony. The brain and the immune system talk constantly. For decades, the brain and immune system were thought to be separate and independent, but we now know they are in continuous communication through multiple channels. The brain sends signals to immune organs through nerve fibers and hormones, influencing the production and activity of immune cells. The immune system sends signals back to the brain through cytokines and other molecules that cross the blood-brain barrier or stimulate peripheral nerves. This bidirectional communication means that mental states affect immune function, and immune states affect mood and cognition. Inflammation in the body can cause depression and fatigue in the brain. Stress in the mind can suppress immune defenses in the body. The discovery of this conversation has transformed our understanding of health and disease. Brain and body are not separate kingdoms but a single realm. Placebo healing is real chemistry triggered by belief. When people believe they are receiving effective treatment, their bodies often produce real physiological changes, even when the treatment is inert. This placebo effect is not imagination, but genuine chemistry, involving the release of endorphins, dopamine, and other molecules that reduce pain and promote healing. Brain imaging studies show that placebos activate the same neural pathways as active drugs. The effect can be enhanced by the ritual of treatment, the confidence of the provider, and the expectations of the patient. Remarkably, placebos can work even when people know they are receiving a placebo, suggesting the ritual itself has power. The placebo effect demonstrates that the mind's expectations can directly influence the body's healing processes. Belief is not separate from biology but woven into it. The chemistry of hope is as real as the chemistry of any pill. The vagus nerve connects emotion to immune response. The vagus nerve is the longest cranial nerve in the body, wandering from the brainstem through the neck and chest to the abdomen, connecting the brain to most major organs. It serves as a major channel for communication between the brain and the immune system, carrying signals that can either enhance or suppress inflammatory responses. Stimulation of the vagus nerve has been shown to reduce inflammation in conditions like rheumatoid arthritis and inflammatory bowel disease. The nerve also transmits information about the body's immune state back to the brain, influencing mood and behavior. Practices that stimulate vagal tone, such as deep breathing, meditation, and cold exposure, have been shown to improve immune function. The vagus nerve is a physical embodiment of the mind-body connection. Through it, our emotional states directly influence our capacity to heal. Compassion lowers the body's baseline of cortisol. Practicing compassion toward oneself and others has been shown to reduce levels of the stress hormone cortisol, creating conditions that favor healing. Self-compassion in particular protects against the harmful effects of self-criticism and rumination, which can keep cortisol levels chronically elevated. Studies of meditation practices focused on loving-kindness and compassion show reductions in inflammatory markers and improvements in immune function. Compassionate people tend to have lower baseline levels of cortisol, even when not actively practicing compassion exercises. The effect appears to involve changes in how the brain processes stress and social connection. Being kind to oneself is not selfishness but self-preservation. The heart that extends compassion to itself and others creates the conditions for its own healing. Oxytocin is both the hormone of bonding and repair. Oxytocin is often called the love hormone for its role in social bonding, trust, and attachment, but it also plays important roles in healing and regeneration. This hormone promotes wound healing by reducing inflammation and stimulating the growth of new blood vessels and skin cells. It also has direct effects on the cardiovascular system, lowering blood pressure and protecting the heart from stress damage. Oxytocin is released during positive social interactions, physical touch, and activities that create feelings of connection. This means that the same experiences that make us feel loved also directly support our physical healing. The hormone bridges the emotional and physiological, translating social bonds into biological benefits. Love and healing share the same molecular messenger. The brain stores immune memories like lessons learned. Recent research has revealed that the brain can store memories of immune responses in a way that influences future reactions to the same pathogens or challenges. This immune memory in the brain is separate from but parallel to the memory stored in immune cells themselves. The brain remembers the context in which infections occurred and can trigger immune responses when those contexts are encountered again. This explains phenomena like conditioned immune responses, where the mere anticipation of a challenge can activate defenses. The discovery suggests that the brain is more deeply involved in immune regulation than previously thought. It learns from past infections and prepares for future ones. The immune system and the nervous system share information across time. The body remembers its battles in more ways than one. Deep breathing alters genes linked to stress repair. Slow, deep breathing has been shown to change the expression of genes involved in stress response, inflammation, and cellular repair. Studies of experienced meditators and people trained in breathing techniques reveal changes in the activity of hundreds of genes compared to non-practitioners. Genes associated with oxidative stress and inflammation are downregulated, while those involved in energy metabolism and immune function are upregulated. These changes occur relatively quickly, with measurable effects appearing after just weeks of regular practice. The mechanism appears to involve signaling pathways that respond to the shift from sympathetic to parasympathetic nervous system dominance that deep breathing creates. Breathing is not just about oxygen exchange, but about sending signals throughout the body. The way we breathe speaks directly to our genes. Deep breathing changes the chemistry of stress hormones. When you breathe slowly and deeply, activating the diaphragm and extending the exhale, you stimulate the vagus nerve and shift the balance of your nervous system toward the parasympathetic rest and digest mode. This shift reduces the production of stress hormones like cortisol and adrenaline, while increasing the release of calming neurotransmitters. The effects can be measured in blood samples taken before and after breathing exercises, showing reduced cortisol and increased markers of relaxation. Regular practice of deep breathing creates lasting changes in baseline hormone levels, keeping the body in a state more favorable for healing even when not actively practicing. The breath is a lever that can shift the entire chemistry of the body. Something as simple as how we breathe can transform our internal environment. Meditation speeds up cellular recovery after stress. Regular meditation practice has been shown to accelerate the recovery of cells from stress-induced damage. Meditators show faster return to baseline of cortisol levels after stressful events and quicker normalization of inflammatory markers. At the cellular level, meditation appears to protect and even lengthen telomeres, the protective caps on chromosomes that shorten with age and stress. People who meditate regularly show signs of biological youth that exceed what would be expected from their chronological age. The effects are dose-dependent, with more practice leading to greater benefits. Meditation seems to work by reducing the chronic low-grade stress that accelerates cellular aging. By calming the mind, we create conditions that allow cells to repair and rejuvenate. Stillness is a form of healing. Meditation can lower blood pressure and aid healing. Numerous studies have demonstrated that regular meditation practice can reduce blood pressure, sometimes by amounts comparable to medication. The reduction appears to result from decreased sympathetic nervous system activity and reduced levels of stress hormones that constrict blood vessels. Lower blood pressure means reduced strain on the heart and blood vessels, allowing them to heal from the microdamage of daily life. Meditation also improves the function of the endothelium, the lining of blood vessels, that regulates blood flow and vessel repair. The effects are not just short-term relaxation, but persistent changes in cardiovascular function that accumulate over time. Patients with heart disease who meditate regularly show improved outcomes and reduced need for medication. The quiet practice of sitting still can heal the hardest working muscle in the body. The human voice can change heart rate variability. The rhythm and tone of the human voice can directly influence the heart rate variability of both the speaker and the listener. Heart rate variability, the variation in time between heartbeats, is a marker of nervous system flexibility and is associated with better health outcomes. Soothing vocal tones and rhythmic speech patterns associated with lullabies and calming voices increase heart rate variability, promoting the parasympathetic state that supports healing. This is why the sound of a caring voice can calm a distressed person, and why certain chanting and singing practices have been used in healing traditions worldwide. The voice carries information beyond the words it speaks, transmitting emotional and physiological states between people. When we speak with warmth and rhythm, we offer our listeners a gift of healing sound. The voice is an instrument of the heart. Healing requires tiny electrical currents through tissues. When tissue is damaged, natural electrical currents arise at the wound site that play essential roles in guiding the healing process. These bioelectric currents are generated by the movement of ions across cell membranes and create voltage gradients that direct cells toward the wound. Skin cells, immune cells, and nerve cells all respond to these electrical signals, migrating toward the area where repair is needed. The current of injury, as it is called, persists throughout the healing process and only subsides when the wound is closed. Medical devices that apply weak electrical currents to wounds can enhance healing, particularly in chronic wounds that have stalled. The body uses electricity not just in the nervous system but as a fundamental guidance signal for repair. Healing flows along currents we cannot see, but that cells can clearly follow. The heart emits a magnetic field detectable several feet away. The electrical activity of the heart generates a magnetic field that extends well beyond the body, detectable with sensitive instruments from several feet away. This field is about 100 times stronger than the magnetic field produced by the brain, and fluctuates with every heartbeat. The heart's magnetic field carries information about emotional states, and can be detected and measured in the space around a person. Research suggests that when two people are in close proximity, their heart fields may interact and influence each other. This biofield phenomenon offers a possible physical mechanism for the intuitive sensing of others' emotional states. The heart radiates its rhythm into the space around us, broadcasting signals that may be received by those nearby. We are surrounded by invisible extensions of our own hearts. Heart rate variability reflects how well you recover. Heart rate variability refers to the natural variation in the time interval between consecutive heartbeats, and it is a powerful indicator of the body's ability to adapt to stress and recover from challenges. High heart rate variability indicates a flexible nervous system that can quickly shift between active and restful states. Low heart rate variability is associated with chronic stress, reduced immune function, and increased risk of disease. Practices that increase heart rate variability, such as slow breathing, meditation, and positive emotional states, are associated with better healing outcomes. Heart rate variability can be measured with simple devices and used as a guide for optimizing recovery. The variability of your heartbeat reflects the resilience of your entire system. A variable heart is a healthy heart. Pain signals tell the brain where to focus healing. Pain is often viewed as pure suffering to be eliminated, but it also serves an important function in directing the body's healing resources. Pain signals alert the brain to the location of damage, triggering responses that increase blood flow to the area and mobilize immune cells. The brain uses pain information to prioritize repair activities, focusing resources where they are most needed. Pain also creates behavioral changes that protect injured areas from further damage, allowing healing to proceed without interruption. While chronic pain serves no useful purpose and should be addressed, acute pain following injury is part of the body's intelligent response to damage. The sensation that makes us guard a wound is also helping to heal it. Pain is the body's way of saying, "Pay attention here." Hormones coordinate healing between organs. The endocrine system serves as a master coordinator of healing, sending hormonal signals through the bloodstream that synchronize repair activities across distant organs. When one part of the body is injured, hormones released from the adrenal glands, pituitary gland and other endocrine organs prepare the entire system to support recovery. Growth hormone stimulates tissue repair throughout the body. Thyroid hormones regulate the metabolic rate of healing cells. Insulin controls the delivery of glucose to fuel repair processes. These hormones work together in complex patterns that change over the course of healing, shifting from early inflammatory phases to later regenerative ones. No organ heals in isolation, but as part of a coordinated whole-body response. The endocrine system ensures that all parts of the body work together toward recovery. Estrogen speeds wound closure. Research has revealed that estrogen plays important roles in wound healing that extend beyond its reproductive functions. Women generally heal from skin wounds faster than men, and this advantage diminishes after menopause when estrogen levels decline. Estrogen promotes the production of collagen and other matrix proteins, stimulates the growth of new blood vessels, and regulates inflammation at wound sites. It also enhances the function of certain immune cells involved in wound healing. Topical estrogen has been explored as a treatment for chronic wounds, with promising results in some studies. The connection between reproductive hormones and tissue repair reflects the body's integration of all its systems. Healing is influenced by hormones we rarely consider in that context. Testosterone can slow certain healing processes. While testosterone is essential for building muscle and bone, elevated levels may actually slow certain aspects of wound healing. Men tend to have stronger inflammatory responses to injury, but slower overall wound closure compared to women. Testosterone appears to dampen some of the signals that promote the later stages of healing, when inflammation needs to resolve and tissue regeneration takes over. This may reflect evolutionary trade-offs between immune defense and tissue repair. The effect varies depending on the type of wound and the tissue involved. Understanding these hormonal influences could lead to treatments that optimize healing for individuals based on their hormonal profiles. The same hormone that builds strength may need to be balanced for optimal repair. Insulin-like growth factor stimulates tissue repair. Insulin-like growth factor 1, produced primarily in the liver in response to growth hormone, is a key mediator of tissue repair throughout the body. This hormone stimulates the growth and division of cells, the production of matrix proteins, and the development of new blood vessels. Levels of insulin-like growth factor increase during healing and are essential for the successful repair of bone, muscle, skin, and other tissues. Low levels, which occur with aging, malnutrition, or chronic illness, are associated with impaired healing. The factor works locally at wound sites, as well as systemically to coordinate repair activities. Ensuring adequate nutrition and sleep helps maintain healthy levels of this important repair signal. growth hormone and its downstream effects are central to the body's regenerative capacity. Adrenaline narrows blood vessels but can delay regrowth. Adrenaline, the hormone of fight or flight, causes blood vessels to constrict, directing blood away from peripheral tissues and toward essential organs. In the short term, this can help reduce bleeding from wounds, which is why adrenaline is included in some local anesthetics. However, prolonged elevation of adrenaline, as occurs during chronic stress, can impair healing by reducing blood flow to tissues that need nutrients and oxygen for repair. Vasoconstriction also limits the delivery of immune cells and growth factors to wound sites. People under chronic stress often have elevated baseline adrenaline levels and heal more slowly as a result. The hormone that prepares us for immediate action can undermine the slow work of recovery. Healing requires the body to step out of emergency mode. The heart releases healing peptides when stressed. When the heart muscle is stretched beyond its normal limits, as occurs during heart failure or other cardiac stress, it releases peptides called atrial and brain natriuretic peptides into the bloodstream. These molecules have been found to have effects beyond their known role in regulating blood pressure and fluid balance. They appear to have anti-inflammatory and anti-fibrotic properties that may protect tissues from damage. Natriuretic peptides have been explored as potential treatments for heart failure and other conditions. The discovery that the heart releases healing signals when stressed adds to our understanding of the organ as more than just a pump. The heart responds to its own distress by producing molecules that may help it recover. Even in crisis, the heart reaches for repair. Cortisol peaks at dawn to end the night's healing cycle. Cortisol follows a strong circadian rhythm, with levels rising sharply in the early morning hours and declining through the day to reach their lowest point around midnight. This morning cortisol surge serves to end the night's sleep and shift the body from repair mode to active mode. During sleep, when cortisol is low, growth hormone is high and tissue repair is most active. The morning cortisol peak signals the body to redirect resources from maintenance to the demands of the waking day. Disruption of this rhythm, as occurs with shift work or jet lag, can impair both sleep quality and healing. Understanding these hormonal rhythms helps explain why good sleep hygiene is essential for recovery. The body heals by night and acts by day, following rhythms set by cortisol's rise and fall. Vitamin C is essential for collagen formation. Collagen, the protein that provides structure to skin, bone, and connective tissue, cannot be properly formed without adequate vitamin C. The vitamin acts as a cofactor for the enzymes that build collagen molecules, and deficiency leads to the breakdown of connective tissue seen in scurvy. Without vitamin C, wounds cannot heal properly, old scars can reopen, and blood vessel walls become fragile. The body cannot produce or store vitamin C, so it must be obtained regularly from the diet. Increased needs during healing may require higher intake than usual. Fresh fruits and vegetables are the primary sources, with citrus fruits, peppers, and leafy greens being particularly rich. The discovery of vitamin C's role in healing was one of the earliest triumphs of nutrition science. This simple nutrient remains essential for every act of repair the body undertakes. Zinc helps cells divide during recovery. Zinc is a trace mineral that plays essential roles in cell division, protein synthesis, and immune function, all of which are critical for healing. It is required for the activity of over 300 enzymes involved in metabolism and repair. Zinc deficiency impairs wound healing, reduces immune function, and slows the production of new cells. The mineral is concentrated in healing tissues and is actively transported to wound sites. Dietary sources include meat, shellfish, legumes, and nuts. zinc supplementation has been shown to accelerate healing in people who are deficient. The body's demand for zinc increases during recovery from injury or illness. Ensuring adequate intake supports the cellular machinery that drives regeneration. Protein is the raw material of regeneration. Proteins are the building blocks from which the body constructs new tissue, and adequate protein intake is essential for healing. When tissue is damaged, the body breaks down dietary protein into amino acids that are reassembled into collagen, muscle fibers, enzymes, and immune cells. Protein needs increase significantly during recovery from injury, surgery, or illness. Insufficient protein intake leads to delayed wound healing, muscle wasting, and increased susceptibility to infection. High-quality protein sources include meat, fish, eggs, dairy, and combinations of plant proteins. The timing of protein intake may also matter, with some evidence suggesting that protein consumed before sleep supports overnight repair processes. Healing is built from protein, molecule by molecule. Wounds heal more slowly without enough iron. Iron is essential for the production of hemoglobin, the molecule that carries oxygen in red blood cells to tissues throughout the body. Without adequate iron, tissues become starved of oxygen and healing slows. Iron is also required for the production of collagen and for the function of immune cells that protect against infection. Iron deficiency is common, particularly in women and people with restricted diets, and can significantly impair recovery from injury or surgery. Red meat is the most bioavailable source, but iron can also be obtained from fortified cereals, legumes, and dark leafy greens. Vitamin C enhances iron absorption from plant sources. Ensuring adequate iron levels supports the oxygen delivery that powers every step of the healing process. Your body produces natural antioxidants in response to injury. When tissue is damaged, the metabolic activity of healing cells generates reactive oxygen species that can cause additional damage if left unchecked. In response, the body upregulates the production of natural antioxidant enzymes like superoxide dismutase, catalase, and glutathione peroxidase. These enzymes neutralize harmful free radicals and protect healing tissue from oxidative damage. The body also draws on antioxidants obtained from the diet, including vitamins C and E, and polyphenols from plants. The balance between oxidative stress and antioxidant defense is carefully regulated during healing, as some reactive oxygen species actually serve useful signaling functions. A diet rich in colorful fruits and vegetables provides the raw materials for this protective system. The body defends its repairs from the chemistry of its own metabolism. The microbiome trains the immune system to respond calmly. The trillions of microorganisms living in your gut play a crucial role in educating your immune system to distinguish between genuine threats and harmless substances. From birth, the developing immune system learns from its interactions with gut bacteria, developing the ability to tolerate beneficial microbes while remaining vigilant against pathogens. A diverse and healthy microbiome promotes immune balance, reducing the risk of both infection and autoimmune disease. Disruption of the microbiome through antibiotics, poor diet, or other factors can lead to an overactive or misdirected immune response. Research has shown that people with healthy gut microbiomes have better regulated inflammation and recover more quickly from immune challenges. The bacteria in your gut are not just passengers but teachers, shaping the behavior of your immune cells. A healthy microbiome creates conditions for calm and effective immune function. Microbiomes in the gut help wounds heal on the skin. The connection between gut health and skin healing may seem surprising, but research has revealed a gut-skin axis that links microbial health to tissue repair throughout the body. Certain gut bacteria produce short-chain fatty acids and other metabolites that enter the bloodstream and influence inflammation and healing at distant sites. Disruption of the gut microbiome has been shown to impair wound healing in the skin, while restoration of healthy gut bacteria can improve outcomes. The gut microbiome also influences the production of immune cells that travel to wound sites. This connection means that digestive health affects far more than digestion. What happens in your gut ripples outward to influence healing throughout your body. Caring for your microbiome is caring for your whole self. Some bacteria teach the immune system how to calm down. Certain species of beneficial bacteria have been found to actively promote anti-inflammatory responses in the host immune system. These bacteria produce molecules that signal immune cells to reduce inflammation and promote tolerance. Species like Lactobacillus and Bifidobacterium have been particularly studied for their ability to calm overactive immune responses. The effect is mediated through various mechanisms, including the production of short-chain fatty acids and the stimulation of regulatory T cells. This calming influence helps prevent the chronic low-grade inflammation that impairs healing and contributes to many diseases. Exposure to diverse bacteria through diet, environment, and lifestyle helps maintain this anti-inflammatory influence. The bacteria that live with us actively participate in keeping our immune responses measured and appropriate. Probiotics can speed recovery after antibiotics. Antibiotics save lives by killing harmful bacteria, but they also devastate the beneficial bacteria that support health and healing. The gut microbiome can take months to recover naturally after a course of antibiotics, during which time immune function and healing capacity may be impaired. Probiotics, which contain live beneficial bacteria, can help speed the recovery of the microbiome and reduce the side effects of antibiotic treatment. Studies have shown that probiotic supplementation during and after antibiotic use reduces diarrhea, supports immune function, and may improve healing outcomes. Not all probiotics are equally effective, and matching the right strains to the situation matters. Fermented foods like yogurt, kefir, and sauerkraut also provide beneficial bacteria. Restoring the microbiome after antibiotics helps restore the body's full capacity for healing. Some people can learn to control their immune systems. For centuries, practitioners of certain meditation and breathing techniques have claimed abilities that science dismissed as impossible, including control over involuntary physiological processes like immune response. Recent research has begun to validate some of these claims, with studies showing that trained individuals can voluntarily influence their immune responses through specific breathing and mental techniques. Participants in these studies have demonstrated the ability to suppress inflammatory responses to bacterial toxins that would normally cause fever and flu-like symptoms. The mechanism appears to involve the voluntary activation of the sympathetic nervous system and the release of adrenaline, which has anti-inflammatory effects. While the techniques require significant training, they suggest that the boundaries between voluntary and involuntary control are more flexible than once believed. The mind may have more influence over the body's defenses than we ever imagined. Cold exposure can trigger cellular cleanup processes. Deliberate exposure to cold activates a cascade of responses that can enhance cellular health and repair. The stress of cold triggers the production of cold shock proteins that protect cells from damage and may help clear misfolded proteins associated with aging and disease. Cold exposure also stimulates the production of brown fat, a type of fat tissue that generates heat and may have beneficial metabolic effects. Brief cold exposure increases noradrenaline, improving focus and mood, while reducing inflammation. Some researchers believe that regular mild cold stress activates cellular maintenance pathways that have been underused in our temperature-controlled modern lives. Cold immersion has become popular for recovery after exercise and injury. The controlled stress of cold may awaken the body's dormant repair mechanisms. Fasting helps cells recycle damaged parts. When the body goes without food for extended periods, cells activate a process called autophagy, in which they break down and recycle their own damaged components. This cellular housekeeping removes dysfunctional proteins and organelles that accumulate over time and can interfere with normal function. Autophagy is essential for maintaining cellular health and has been linked to longevity and disease prevention. The process is suppressed when nutrients are constantly available, as they are in modern eating patterns. Periodic fasting or time-restricted eating can reactivate autophagy and support the body's natural maintenance systems. The practice has been part of healing and spiritual traditions across many cultures throughout history. Sometimes the body heals best when it is given a break from the work of digestion. Exercise signals the body to start regenerative pathways. Physical exercise is one of the most powerful triggers of the body's regenerative processes. When muscles contract and demand resources, they release signaling molecules called myokines that have effects throughout the body. These signals promote the growth of new blood vessels, enhance mitochondrial function, reduce inflammation, and stimulate the production of growth factors. Regular exercise has been shown to improve wound healing, strengthen immune function, and slow many aspects of biological aging. The stress of exercise activates cellular defense and repair pathways that remain active long after the exercise session ends. Even moderate physical activity can provide significant benefits for healing and regeneration. The body interprets the demands of movement as a signal to invest in its own maintenance. Motion is medicine that the body prescribes to itself. Wounds heal more slowly in space without gravity. In the microgravity environment of space, many of the body's normal functions are disrupted, including the process of wound healing. Experiments on the International Space Station have shown that wounds take longer to close and heal less completely than they would on Earth. The cells responsible for healing behave differently without gravity, moving more slowly and failing to form the organized structures needed for effective repair. Blood flow is altered, inflammatory responses are changed, and the delivery of healing factors to wound sites is impaired. Astronauts on long-duration missions face increased risk from even minor injuries. Understanding how gravity affects healing is essential for planning future missions to the Moon and Mars, where medical emergencies may occur far from Earth. The pull of Earth that we rarely notice is quietly essential for our bodies to repair themselves. Gravity helps guide circulation and tissue repair. Gravity plays important roles in blood circulation, fluid distribution, and the movement of cells throughout the body that we take for granted on Earth. Blood pressure gradients created by gravity help drive circulation and ensure that oxygen and nutrients reach all tissues. The mechanical stress that gravity places on bones and muscles signals them to maintain their strength. In the absence of gravity, fluid shifts toward the head, blood pressure regulation is disrupted, and the signals that maintain bone density are lost. These changes have consequences for healing, as the normal patterns of blood flow and cellular movement that support repair are disrupted. Astronauts returning to Earth often require time for their circulation and tissues to readapt to gravity's pull. We evolved under gravity, and our healing processes are tuned to its constant presence. The body's repair systems work in rhythmic waves. Healing does not proceed in a steady line, but unfolds in waves and cycles that follow rhythms built into the fabric of life. Inflammatory phases alternate with regenerative phases. Activity cycles with rest. The body pulses between building up and breaking down, between defense and restoration. These rhythms operate on multiple timescales, from the rapid cycles of cellular metabolism to the slow rhythms of tissue remodeling that unfold over months. Understanding these waves helps explain why healing sometimes seems to stall or reverse before progressing again. The rhythmic nature of healing also suggests that timing matters in treatment, with interventions potentially more effective when aligned with the body's natural cycles. Healing dances to rhythms older than language, older than memory, woven into the very nature of living systems. The immune system follows a 24-hour rhythm. The immune system does not function at the same level throughout the day, but follows strong circadian rhythms that affect its activity and effectiveness. Certain immune cells are more numerous in the blood during the day, while others predominate at night. Inflammatory responses tend to be strongest in the morning and diminish toward evening. This rhythmicity means that infections encountered at different times of day may trigger different responses. Vaccines given in the morning may produce stronger immune responses than those given in the afternoon. Sleep disruption, which disturbs circadian rhythms, has been shown to impair immune function and slow healing. The immune system is tuned to the cycle of day and night, preparing for the threats most likely at each time. Defense follows the rhythm of the sun. Wounds remember how they healed before. Tissues that have healed from previous injuries appear to retain a kind of memory that influences how they respond to future damage. Cells in previously wounded areas may remain primed for rapid response, or they may be scarred in ways that alter their behavior. Some research suggests that tissues can learn from past healing experiences, becoming more efficient at repair. Other studies show that repeated wounding in the same area can lead to altered healing responses. This tissue memory may involve epigenetic changes, alterations in the local cell populations, or persistent changes in the extracellular matrix. The body carries its history in its tissues, and past healings influence future ones. Every wound leaves not just a scar but a lesson. The body stores physical memories of trauma. Beyond the psychological memories of traumatic events, the body itself appears to store physical traces of trauma in its tissues. Chronic muscle tension patterns, altered posture, and persistent pain can all represent the body's ongoing response to past injuries or frightening experiences. These physical memories may be encoded in fascial tissue, in the nervous system's calibration of threat responses, or in the immune system's baseline level of activation. Therapies that address the body directly, such as massage, movement therapy, and somatic experiencing, can sometimes release these stored patterns. The recognition that trauma lives in the body as well as the mind has transformed approaches to healing from violence, accidents, and other overwhelming experiences. The body remembers what the mind may have forgotten. Healing can release old cellular stress patterns. When the body heals from current injuries or illnesses, the process sometimes releases older patterns of stress and dysfunction that had been stored in tissues. Patients undergoing deep tissue therapy or recovering from surgery sometimes report emotional releases or the resurfacing of old symptoms. This phenomenon suggests that healing processes can reach deeper than the immediate injury, addressing layers of accumulated cellular stress. The release may involve the clearing of stored inflammatory signals, the reorganization of fascial tissue, or the resetting of nervous system patterns. Not all healing is purely mechanical. Sometimes it involves a kind of unwinding of the body's history. Recovery from one injury can open the door to healing from older ones. The body heals not just forward but backward through time. Neuroplasticity lets the brain heal long after injury. The brain's ability to reorganize itself and form new neural connections continues throughout life and offers hope for recovery long after the initial injury. People who suffered strokes or head injuries years ago can still make gains in function through targeted rehabilitation. The brain constantly adapts to experience, strengthening connections that are used and pruning those that are not. This plasticity means that it is never too late to begin working on recovery. New learning, physical therapy, and cognitive exercises can all promote beneficial brain changes. Even old patterns of chronic pain or dysfunction can sometimes be addressed through approaches that harness neuroplasticity. The brain that seemed fixed is actually fluid and adaptable. Healing can continue as long as life itself continues. Mirror therapy can help retrain nerves after amputation. One of the most remarkable discoveries in rehabilitation medicine is that looking at a mirror reflection of an intact limb can help the brain rewire itself after amputation. Patients with phantom limb pain often find relief when they view their intact limb moving in a mirror positioned to make it appear where the missing limb would be. The brain seems to accept the visual feedback and update its internal map, reducing the pain signals from the absent limb. Mirror therapy has been extended to treat other conditions involving motor and sensory dysfunction. The technique demonstrates the power of visual feedback to influence neural processing and highlights how deeply perception and physical sensation are intertwined. The brain can be fooled into healing by a simple reflection. Pain teaches the brain to protect and eventually to let go. Pain is not merely a symptom, but a teacher that shapes the brain's responses to injury and threat. Acute pain teaches the brain to avoid movements and situations that cause damage, protecting healing tissue from further harm. As healing progresses, the brain must learn to let go of these protective responses and allow normal function to resume. When this process goes well, pain fades as healing completes. When it goes poorly, chronic pain can persist long after the original injury has healed. Retraining the brain to release unnecessary pain responses is a key focus of modern pain rehabilitation. The same plasticity that allowed pain patterns to become established can be harnessed to dismantle them. Pain teaches protection, but the final lesson is release. Healing is the body's most ancient language of life. Long before the first creature could think or feel, the capacity to repair damage was already essential for survival. The mechanisms of healing are older than brains, older than hearts, older than bones. Single-celled organisms heal their membranes when punctured. The simplest animals regenerate lost parts. The molecular machinery of repair is conserved across species and across billions of years of evolution. When you heal from a cut or recover from an illness, you are participating in processes that connect you to every living thing that has ever existed. Healing is not just biology, but a kind of inheritance, a gift passed down through countless generations. It is the body's oldest wisdom, its most fundamental act of self-affirmation. To heal is to declare that life continues. And now the quiet wonders of healing begin to gently fade into the stillness of the night. You have wandered through over 100 soft truths about the remarkable systems that keep you whole. From the cells that rebuild your skin and bones, to the nerves that rewire themselves after injury. From the immune system's careful memory to the heart's magnetic rhythm of renewal. You have explored how sleep restores what waking hours wear down. how laughter and tears and human connection all shift your chemistry toward recovery, how light and breath and gratitude all play their part in the ancient art of repair. You are part of this story, not just an observer, but a living, breathing example of healing in action. Right now, even as you rest, your body is at work in silence. Cells are dividing. Nerves are reconnecting. The quiet pulse of renewal is moving through you with perfect patience. If your eyes feel heavy now, let them close. Let the rhythm of your breath become steady, like the gentle beat of a heart that has been healing you since before you were born. Like the soft hum of cells that have never forgotten how to restore what is broken. Tonight, as you rest, your body continues its quiet work. DNA is being repaired. Inflammation is cooling. The immune system is patrolling, protecting, and preparing for tomorrow. Somewhere deep inside, stem cells are stirring, ready to answer the next call for renewal. You are a small, warm presence within this vast living system, peacefully resting among the wonders. Sleep well, sweet dreams, and may you carry with you the quiet knowledge that your body has been healing itself since the very first heartbeat, and will continue its patient work long after the last thought of the day has faded into peaceful darkness. Thank you for joining me on this journey through the science of healing. If you enjoyed this video, please subscribe to Drowsy Discovery for more soothing explorations of how your body and mind work together. There are more wonders waiting, more secrets hidden in the chemistry of sleep and the rhythm of the heart, more gentle truths to drift through on quiet evenings. Rest well, and may the quiet wisdom of your own biology keep you company through the night. This has been Drowsy Discovery. Good night.